set of points in a plane at a given distance from a given point in that plane. The given point is the center of the circle, and the given distance is the radius. Any segment that joins the center to a point of the circle is called a radius. All radii of a circle are congruent. A chord is a segment whose endpoints lie on a circle. A secant is a line that contains a chord. A diameter is a chord that contains the center of a circle. A tangent is a line in the plane of a circle that intersects the circle in exactly one point called the point of tangency. Line AT is tangent to circle O at point A. Many of the terms used with spheres are the same as those used with circles. Now solve these problems! Segments OA, OB, and OD are radii. Line CB is a secant. Line AT is tangent to circle O. BD is a diameter. Congruent circles are circles that have congruent radii. Concentric circles are circles that lie in the same plane and have the same center. The radii of concentric circles are different. A point is inscribed in a circle, and the circle is circumscribed about the polygon when each vertex of the polygon lies on the circle. Theorem 9.1.
If a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency.
Corollary.
Tangents to a circle from a point are congruent.
Theorem 9.2.
Theorem 9.2 is the converse of Theorem 9.1. It states that if a line in the plane of a circle is perpendicular to a radius at its outer endpoint, then the line is tangent to the circle.
Unbroken part of a circle. Y and Z and the points of circle O in the interior of angle YOZ form a minor arc. Y and Z and the remaining points of circle O form a major arc. If Y and Z are the endpoints of a diameter, then the two arcs are called semicircles. A minor arc is named by its endpoints. You use three letters to name a semicircle or a major arc. The measure of a minor arc is defined to be the measure of its central angle. In the diagram below, the measure of YZ represents the measure of minor arc YZ. Next diagram, can you see why the measure of a major arc is 360 minus the measure of its minor arc? The measure of a semicircle is 180. Adjacent arcs of the circle are arcs that have exactly one point in common.
Postulate 16, the arc addition postulate.
The measure of the arc formed by two adjacent arcs is the sum of the measure of these two arcs. In the example, measure of arc AB plus measure of arc BC is equal to 75 plus 85, which is 160 degrees. Congruent arcs are arcs in the same circle or congruent circles that have equal measures. Notice that each of the congruent arcs has an 80-degree central angle, so these congruent arcs have congruent central angles. The relationship between congruence of minor arcs and congruence of their circle central angles is stated in Theorem 9.3.
Theorem 9.
In the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent.
Theorem 9.4. In the same circle or in congruent circles, Congruent arcs have congruent chords, and congruent chords have congruent arcs. A point y is called the midpoint of arc xyz if arc xy is congruent to arc yz. Any line, segment, or ray that contains y bisects arc xyz.
Theorem 9-5.
A diameter that is perpendicular to a chord bisects the chord and its arc. In the diagram, since chord CD is perpendicular to chord AB, line segment AZ is congruent to arc line segment BZ, and arc AD is congruent to arc BD. Recall that the distance from a point to a line is the length of the perpendicular segment from the point to the line. This definition is used in the following example. Find the length of a chord that is a distance 5 from the center of the circle with radius A.
Now you solve the problem.
Solution. By using the Pythagorean theorem, we know that x squared plus 5 squared equals 8 squared. X equals rad 39, which is AP. By theorem 9.5, OP bisects AB, so AB equals 2AP, which is 2 rad 39. Theorem 9.6. In the same circle or in congruent circles, chords equally distant from the center or centers are congruent. Congruent chords are equally distant from the center or centers. Example 2. Find the value of x. Solution. S is the midpoint of RT, so RT equals 6 by theorem 9.5. RT is then congruent to UV, so x equals 4 by theorem 9.6.
Angles 1 and 2 shown at the right are called inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. We say that the angles at the right intercept the arc shown in color. Angle 1 intercepts a minor arc. Angle 2 intercepts a major arc. Theorem 9.7. The measure of an inscribed angle is equal to half the measure of its intercepted arc. Find the values of x and y in circle O. Solution. Measure of angle PTQ equals half of measure of arc PQ. So, angle PTQ equals half of 40, which is equal to 20, which is equal to x. Measure of angle PSR equals half of measure of arc PO. 50 equals half of 40 plus y equals 60.
Corollary 1. If two inscribed angles intercept the same arc, then the angles are congruent. In the diagram shown, angle 1 is congruent to angle 2. Corollary 2. An angle inscribed in a semicircle is a right angle. If arc MXN is a semicircle, then angle X is a right angle. Corollary 3. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Angle E is supplementary to angle G, and angle F is supplementary to angle H.
Okay. Find the values of x, y, and z.
Now you solve the problem.
Solution. Angles ADB and ACB intercept the same arc, so x equals 40 by corollary 1. Angle ABC is inscribed in a semicircle, so ABC is a right angle and y equals 90 by corollary 2. ABCD is an inscribed quadrilateral, so angle BAD and angle BCD are supplementary by corollary 3. Z equals 180 minus x plus 30. X equals 40, so z equals 110.
9-8.
The measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc.
For example, if line PT is tangent to the circle and AT is a chord, then angle ATP intercepts arc AT, and measure of angle ATP equals half measure of arc AT, which is half of 140, which is 70.
Theorem 0.999.
The measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intersected arcs.
In the diagram, measure of angle 1 equals half the measure of arc AC plus arc of CD.
0.910.
The measure of an angle formed by two secants, two tangents, or a secant and a tangent drawn from a point outside a circle is equal to half the difference of the measure of the intercepted arcs.
Basically, the theorem is stating that in these three cases, the measure of angle 1 is equal to half the measure of x minus y.
Tar, you're like tar.
Circles shown AP and PB are segments of chord AB. Theorem 911. When two chords intersect inside a circle, the product of the segments on one chord equals the product of the segments of the other chord.
In the diagram, R times S equals T times U.
Theorem 912. When two secant segments are drawn to a circle from an external point, the product of one secant segment and its external segment equals the product of the other secant segment and its external segment.
Example 1. Find the measures of angle 1 and angle 2. Solution. Measure of angle 1 equals half measure of arc CE plus measure of arc FD. Theorem 913. When a secant segment and a tangent segment are drawn to a circle from an external point, the product of the secant segment and its external segment is equal to the square of the tangent segment.
Example 1. Find the values of x and y. Solution. X equals 9, y equals 6.
Thanks for watching!